Alright guys, welcome to this video. We are doing a review today on Unit 5 of AP Calc AB or BC. It doesn't matter which course you're taking because Unit 5 overlaps 100% with both of these guys. The other units are already out, I think the older units. So there's a link in the description. You can click on it, you can check that out. You can even download these worksheets and all, try on your own first. We are going to cover all the topics that are all the concepts that are tested in this particular unit. Like it says, no calculator unless otherwise stated. If you have any questions, post it down in the comment section, and if you need private tutoring, feel free to reach out. All right. Let f be a function defined on 2 to 6 and f2 is equal to f6, and the following properties that f might have. The first property is f is continuous on 2 to 6 closed interval and differentiable on the open interval. Okay, fair enough. Fx is this and then fx this is. Which properties ensures that there exists at least one c in this such that f prime c is... What does this remind you of? This setup that f2 is equal to f6 and f prime c is equal to 0 reminds me of Rolle's theorem. I hope it reminds you as well of Rolle's theorem. And Rolle's theorem states that if a function is continuous in a closed interval and differentiable in an open interval, and fa is equal to fb, as in f2 is equal to f6, then there exists at least one value of c within the interval of 2 to 6 such that the derivative at that point is 0. That's what Rolle's theorem suggests. So 1 definitely works for, because isn't that just the definition of Rolle's theorem? 2 also works because cos cube x is continuous always and differentiable always, right? The trig functions, sinusoidal functions are always continuous and differentiable. So 2 works, but be careful. This guy will not work because we know that absolute value guys form a sharp corner wherever the inside guy is 0, or in other words, x is equal to 4 in this case. So at x equal to 4, it is a sharp corner, and sharp corners are not differentiable. And since within this, there is a point where it is not differentiable, so 2 is definitely, 3 is definitely not correct. So 1 and 2 both will work. So the answer has to be B in this case, option B. All right, determine if the function satisfies the hypothesis for MVT. If it does, then find all the possible values of C satisfying. Okay, MVT is what? There's just one condition of Rolle that is not an MVT, which is F0 is equal to F1. That we don't care about. We just care about whether it is continuous in the closed interval and differentiable in the open interval. So yes, this guy is definitely continuous because x is a cube root, so there is no such thing that is making this undefined at any point between 0 and 1, and this is also continuous. And yes, these guys are definitely not differentiable at for example, x equal to 1, because in this case x equal to 1 is forming a vertical tangent, or x equal to 0 over here is forming a bird or a cusp. But like I said, differentiability is on the open interval, not a closed interval. So yes, this is continuous between 0 and 1 closed interval, and this is differentiable in 0 to 1 open interval. So since this happens, differentiable in the open interval. So since both these happen, this is definitely, MVT is definitely applicable. Now what is MVT? MVT says that f prime c is fb minus fa over b minus a. Let's find fa or f0 first. So honestly, that's just 0, right? Because you put 0 here, you put 0 here, and 0 times anything is 0. So I'm getting 0 plus 0, which is just 0. And let's find f of b, which is f of 1. So that will be 1 plus 1 raised to 2 over 3, 1 minus 1 to the 1 over 3, which is 1 plus 0, which is just 1. And the derivative, okay, the derivative is going to be fun. So f prime x is going to be 1, that is the derivative of x, and here I need to use a product rule. So x to the 2 over 3 as it is, then 1 over 3, 1 minus x to the minus 2 over 3 times minus 1, plus 1 minus x raised to 1 over 3 as it is, and then 2 over 3 x to the negative 1 over 3 as the other thing. By the way, let's complete this thing. This is fb, which is 1 minus 0 over 1 minus 0, which is just 1. So I want that to be equal to 1. Okay, well. So this is 1 minus, because there's a minus from here, 1/3 x to the 2 over 3 and 1 over 1 minus x to the 2 over 3. I just brought this negative power in the denominator to make it positive. And the other guy is 2 over 3, and again this is a negative power, so let's bring it to the reciprocal, and this will be 1 minus x to the 1 over 3. And I want this f prime guy to be equal to that fb minus fa over b minus a, which is just 1. So let's put 1 over here. This 1 and 1 is crossed out. This 1 and 1 is crossed out. And I'm going to move this entire thing on the left side. So it's going to look like 1 over 3 x to the 2 over 3 over 1 minus x to the 2 over 3 is equal to 2 over 3, 1 over x to the 1 over 3, and 1 minus x to the 1 over 3. Annoying, right? I know. 3 gone from both the sides. Let's cross multiply. So x to the 2 over 3 is multiplied by x to the 1 over 3. It won't be annoying anymore. And then here 2 times 1 minus x to the 2 over 3 is comes here, times 1 minus x to the 1 over 3. Base is same, power is added, so it will just become x, because 2 over 3 plus 1 over 3 is 1. And likewise, base is same, power is added, so 2 over 3 plus 1 over 3 is again 1. So x is equal to 2 minus 2x. I just, distributed, adding 2x both the sides, so 3x is equal to 2, and x finally, oh my goodness, this 2 over 3. Unfortunately, 2 over 3 is also in the options, and 2 over 3 is also between 0 and 1. That's something that we have to make sure. So our answer, my dear friends, is option A. Okay. Which of the following functions satisfies the hypothesis of the MVT? Okay. I think this does, because it is always continuous. I mean, obviously not continuous at -2, but I'm not bothered. It is always continuous between 0 and 2. There is no such point that can make it discontinuous. And it is always differentiable as well. I mean, again, it is not differentiable at -2, but -2 is not here. So 1 definitely meets the criteria. So it cannot be option D. Okay, this guy, be careful. It's not differentiable at x equal to 1 over 2 right away. I think by this time you should be in a habit of seeing the powers of 1 over 3 and 2 over 3. These guys are so popular that x minus a raised to 1 over 3 and x minus a raised to 2 over 3. At x equal to a, these guys are not differentiable, this one, because it forms a vertical tangent. Remember, I'm saying vertical tangent. I'm not saying vertical asymptote. It is continuous but not differentiable because of vertical tangent. It is continuous but not differentiable because of cusp, which is basically a bird function. You must have heard this in your school probably. That's what they call it. It's a bird function, something like that. And cusp is like something like that. Vertical tangent is something like that. Okay, so right off the bat, I know that x equal to 1 over 2, this is a vertical tangent. Unfortunately, 1 over 2 is between 0 and 1, so this is gone. Nope. And this guy, I think, yes, it has a sharp corner at x equal to 0. It is something like this. But once again, I'm not really bothered at x equal to 0 because it's not differentiable at x equal to 0, but the differentiability is checked in open interval, not closed interval in MVT. So this was a touch and go case, but it is accepted. So answer is 1 and 3. Yeah, option C makes the perfect sense. Right, selected values of differential data, which of the following could be false? By the intermediate value theorem, Okay, by the way, this is a differentiable function. So whenever they say that a function is differentiable, it is automatically continuous, right? Because a discontinuous function can never be differentiable everywhere. By intermediate value theorem applied to the function in the interval 2 to 5, there is a value of c such that fc is equal to 10. This is true. They are asking what is false. So this is true, right? This is classic IVT, not of this unit, but I hope you remember IVT is just that since it is continuous between 2 to 5, so all the values between 1 to 31 will be possible, and 10 is between that. So since this is true, this is not our answer. We are again looking for false statements. By MVT applied to the function in 2 to 5, yes, we can apply that. There is a value of c such that f prime c is 10. We need to find that. Let's find f5 minus f2 over 5 minus 2. f5 is 31, f2 is 1, this is 3, so 30 over 10 is 10. Well, this is also true. So this is also true, not interested. By Rolle's theorem, in 2 to 5, there is a value of c such that f prime c is 0. Uh, really? Well, I don't really see any two values that are equal, at least over here. So I think this could be false because Rolle's theorem is only applicable when any two functional values are equal. I'm going to place a question mark here. Let's read the last one. By extreme value theorem, there is a value of c in 2 to 5 such that fc is less than equal to for all values between 0 to 3. Sorry guys, there is a slight correction here. This should be 2 to 5, not 0 to 3. So please make sure you make that correction. And yes, this is also 100% true because extreme value theorem, this is just a fancy way of saying there is a global minima. And yes, global minima occurs definitely between any 2 points if the function is always continuous. And yes, it is continuous. So between 2 and 5, there will be a global minima and there will be a global maxima as well. That's what it suggests. So yes, our speculation is correct. The answer is indeed option C. Right. Consider this differential equation. All right, guys, this looks like a tangent line approximation question. And fx be the particular solution to the differential equation with the initial condition f2 is 0. They're asking me to find the equation of the line tangent to the graph at this point. So, of course, line tangent needs a point and a slope. I have a point. I need the slope. So all I need to do is plug this point over here. So the equation or the slope is going to look like dy over dx will be equal to replacing y by 0 and x by 2. This is how it will look. E to 0 is 1, 2 squared is 4, 4 times 2 is 8, 5 times 2 is 10, so this is negative 2. So I have the equation now, and the equation of the tangent line is going to look like y minus 0 is equal to negative 2 times x minus 2. So it will be y is equal to negative 2x plus 4. That's our answer to question number A. Then they're asking use the tangent line to approximate 2.2. So all you have to do is plug in 2.2 over here because tangent line approximation is used to approximate the value of any point that is closer to this point. I mean, practically it makes sense only when you're picking a point that is closer to this one. So if I put 2.2 over here, my answer will be negative 2 times 2.2 plus 4, which is negative 4.4 plus 4, which is negative 0.4. That should be the approximation. Okay, find the absolute extrema of this. Candidates test, guys. Candidates test. I hope you remember what a candidates test is. The first step is to differentiate and find the critical points. Let's do that. This is a pretty easy function. So f prime x will be equal to 3x squared minus 5 over 2 times 2x, gone. So this will be 3x squared minus 5x. X can be factored out, so it will be 3x minus 5. That is f prime x. To find the critical point, we equate the derivative to 0 or undefined. This cannot really be undefined, right? This is a polynomial, but this can definitely be 0. So if I equate x times 3x minus 5 to 0, this means that x is 0 and 3x minus 5 is 0, which means that 3x is 5, which means that x is 5 over 3. Next step is to make a table and find the functional value at these points. What I want to say is I usually make a table, and along with the critical points, you need to find the functional value at the end points as well, as in -1 and 2. So I'm going to write -1 here, 0 here, 5 over 3 here, and 2 here. And you're going to, we are supposed to plug all these points into the original function and find out how it works. So if I put -1 cube is still -1, and -1 square is just 1. So -1 minus 5 over 2 is -7 over 2. So -7 over 2. If I plug in 0, obviously this is just 0. If I plug in 2, 2 cube is 8 and 2 square is 4. So it will be 8 minus 10, which is -2. So -2. And if I plug in 5 over 3, then 5 over 3 cube minus 5 over 2 times 5 over 3 square. We can take 5 over 3 square as a factor. What are we looking for, by the way? Absolute extrema. Okay, so minima and maxima both. So this will become 5 over 3 minus 5 over 2. So this will become 25 over 9 times, I think this is, if I'm not wrong, over 6. 3 times 2 is 6, and 10 minus 15 is minus 5. So that's coming as a negative number, okay? -125 over 54, that's what I have. So -125 over 54. So clearly, global maxima is this. This is global maxima because this is the maximum value. So global maxima is this. And the minimum value is -3.5 because this, guys, is not even 3. It would have been 3 had this was 150, more than 150, the numerator. So it's not even 3. And this guy is, I mean, it's not even -3. And this guy is -3.5. So this guy is the global maxima, minima. So we got both the global minima as well as the global maxima from candidate's test. That's how it works. I can write the coordinate pair for you. This is 0, 0, and this is -1 comma -7 over 2. That's how it works. Okay, find the point at which this has the maximum. That again, a candidate's test, this time will trigonometry. So again, I'm gonna find the derivative h prime x, which is 3 cosine x, and I'm gonna equate it to 0 because undefined is not possible. Remembering unit circle, guys, when is cos x 0? When x is on the y-axis, basically. When x is pi over 2 and 3 pi over 2. Let's find the functional values. Instead of making a table, I'll just write like h0, h pi over 2, h3 pi over 2, and h2 pi. From where is this 0 and 2 pi coming from? These are the endpoints of the interval. We have to check at those points as well. What is h of 0? Remember, you need to put in the original function, not the derivative. So h of 0 is 3 times sine 0. Sine 0 is 0, so 0 plus 1 is 1. H of pi over 2, sine of pi over 2 is 1, so 3 plus 1 is 4. H of 3 pi over 2, sine 3 pi over 2 is -1. -3 plus 1 is -2. And h of 2 pi, sine 2 pi is 0, so that's 1. They're looking for the maximum, and clearly the maximum is right over here. So the global maxima is going to be pi over 2 comma 4. This is the global maxima over here. Right, guys, I hope you understand this. Okay. Next question what we have is, once again, guys, if you're finding this video helpful so far, please like it, please share it with your friends. It's going to really help them. And it will help me as well. And if you need private tutoring, feel free to reach out. Okay, now we are talking about when is the function increasing and where are the relative extremas. So increasing and relative extremas are all about first derivative and doing the sign chart on the first derivative, right, guys? So what are we looking at here? It's a simple polynomial. F prime is 3x squared minus 6x minus 9. I'm going to take 3 out, so it will be x squared minus 2x minus 3. And this can be factored very easily as x minus 3, x plus 1. So if I make a sign chart over here, this will be -1, this will be 3. And I hope you guys know a shortcut. I think I've been talking about that earlier, but I can explain it again. If the powers of all the factors that we have is odd, doesn't matter how big or small that is. For example, here it is just 1. Even if it is 101, then all you need to do is find this sign. For example, if you put anything greater than 3, maybe 100, so it will be positive. And then just blindly toggle the signs. No need to plug the numbers again and again. This is always going to happen provided the powers are odd. So they want increasing. Increasing is wherever f prime is positive. So the answer is negative infinity to -1, union 3 to infinity. And for what values of x does f have relative minimums or relative maximum? So relative minimum wherever this happens, right? Sorry, this happens, x equal to 3. Because relative minimums where the derivative changes from negative to positive, so x equal to 3. And maximums where it's plus to minus, so x equal to -1 is the relative maxima. Oh, there's more. For what values of x does this have point of inflection? So point of inflection is all about the double derivatives. So let's find the double derivative of this one. So f double prime is going to be what? 6x minus 6, right? Okay, so that's pretty straightforward, I think, in my opinion. If I just take a 6 out, I'm left with x minus 1. And when we equate this double derivative to 0, we will get x equal to 1. I will make a sign chart at 1. Anything on the right, maybe 100, positive, negative. And yes, this ensures that 1 is inflection. Remember, this is not the point where we can just stop and conclude that 1 is inflection, because at inflection point, the double derivative must have a sign change. And yes, this ensures that it has a sign change. Over here, it is concave down. Over here, it is concave up, the original function. So yes, x equal to 1 is definitely an inflection point. Okay, all right, guys. Oh, now we're talking about graphs. Oh my God, that's a big question. All right, y is equal to g prime x. This is the graph of g prime x. Remember, g prime x, not gx. Determine where g has horizontal tangents and justify your answer. G has horizontal tangents wherever g prime is 0. And fortunately, we know the graph of g prime. So wherever g prime is 0, and I do see 3 points where the g prime is 0, so our answer should be x is equal to -5, x is equal to 2, and x is equal to 9. That's where the g prime is 0. What are the critical points of G? Well, critical points of G are wherever G prime is 0 or undefined. Well, I don't really see any such points where the G prime is undefined. I don't see any vertical tangent or anything like that. So I'm again going to stick with G prime equal to 0, which honestly I already have, right? So the answer will be -5 and 2 and 9. These are the points where the G prime is 0. For each critical number, determine if G has a relative min, max, or neither. And that depends on the sign change, guys, as we already know. So for example, I can make a number line here, -5, 2, and 9. And we don't even have to plug in the numbers. We just have to look at the graph. If you look at -5, it is changing from negative to positive because it is below the x-axis and above the x-axis. At 2, it is not really changing because it was positive before and positive after. And after 9, it is negative. This makes it very clear that the relative minima will be at x equal to -5 because it is changing from negative to positive. What is changing? G prime. And it is from positive to negative. So for x equal to 9, it should be a maxima. So that's how these things work over here. On what intervals is G decreasing? So G is decreasing wherever G prime is negative. G prime is negative, and G prime is negative when it is below the x-axis because this is the graph of G prime. So this is one interval and this is another interval. So I'm going to answer that it is going to happen from -infinity to -5 union 9 to infinity. That's where this thing is going to happen. Next, you're asking during which interval is G double prime negative? Okay, that's a little confusing. Why? Because G prime graph is given. G double prime is negative means G is concave down. Everyone knows that. But not helpful here because the graph of G is not given. So G double prime x is negative or less than 0 also means that G prime of x is decreasing. Think about it like that. Whenever any function is decreasing, think about it just like a function. This is a function. And if this function is decreasing, its immediate next derivative should be negative. And that's what is happening over here, right? This is helpful because we are given the graph of G prime x. So all I have to find is where it is decreasing. So it is decreasing from here to here and here to here. So the answer is going to be, I think, -2 to 2. That's the first thing. -2 to 2. And the other thing is, I think, 6 to infinity, right? So 6 to infinity. That's the other interval where it is decreasing. Where exactly is it concave up? So again, concave up, G is concave up wherever G prime is greater than 0, and G double prime is greater than 0 wherever G prime is increasing. So it is increasing in the interval from -infinity to -2, the other part that we didn't take earlier, and 2 to 6. So -infinity to -2 and 2 to 6. That should be our answer. -infinity to -2 union 2 to 6. That should be our answer. And oh my goodness, this question will never end. On what intervals is G both decreasing and concave down? Fortunately, I have both the things right here on this window. G is decreasing here and G is concave up, sorry, decreasing and concave up here. So just find a common interval where both are happy. I'm going to make a number line. I'm going to plot -5 and 9 first and say that it is decreasing from -infinity to -9 and 9 to infinity. And then concave up, I'm going to plot -2 here and 6 here. And I'm going to say that this is -infinity to -2 and 2 to 6. Okay, sorry, I need a 2 as well. Then 2 to 6 over here. Okay, this is where it is concave up. Where are both of them happy? Where is the top line matching with the bottom? I think only this interval, only this piece, right? That's where both are happy. So my final answer is -infinity to -5. That's where it is both in decreasing and concave up. I hope you understand. And for what values of x does G have a possible point of inflection? So G has a point of inflection wherever G double prime is going to be 0 or undefined. And they're asking possible point of inflection. So yes, for it to be 100% true, the G double prime should also change the sign. But in other words, I can also say that because I need to, work in terms of G prime. So G double prime will be 0. How will I see that G double prime is 0 or undefined? Obviously, the derivative of this function, which is already G prime, is never undefined. There is no vertical tangent. But yes, the derivative is definitely 0 at here, at these 3 points. That's where the derivative is 0. And this is G prime and its derivative is G double prime because these are horizontal tangent lines. So the possible points of inflection are -2, 2, and 6. Why am I saying possible points? Is because I'm not really checking whether G double prime is changing its sign or not. Although this is a little weird question because they don't really ask about possibilities. They just ask about whether it is or not. But to be precise that whether these points are inflections or not, actually they are. Because if you notice carefully, in this portion, G prime is increasing, which means that G double prime is positive. Then this is decreasing, so G double prime is negative, and then increasing, and then decreasing. So actually, -2, 2, and 6 are the points of inflection. -2, 2, and 6 are points of inflection. It's not about whether they are or possible or not. 100% they are points of inflection. So that should be our answer. Right, here we are given f prime x and they're asking for what values of x does f have a relative extrema. That's easy because f prime is already given. So I'm just gonna set f prime to 0 and then find the, what do you call it as? Sign chart. So 3x square x minus 4 x plus 2 should be equal to 0, which gives me from here x equal to 0, from here x equal to 4, from here x equal to -2. Let's plot a number line. So this is -2, this is 0, this is 4. Anything greater than 4, let's call it 100. Remember, I'm using a first derivative test, so I'm gonna put my numbers in the first derivative. Anything greater than 4, maybe 100. This is gonna be positive. Let's put 1 here. So 1, I don't think so I need to ask this guy again and again because this is always positive. So 1 will make this negative and this positive, so overall negative. Then put -1, which will make this negative, this positive again. So it is again minus. And put -100, so this will make it this negative, this negative. So yes, a double negative will make it positive. They're asking relative minima or maxima. So this is relative maxima. X equal to -2 is relative maxima because it's changing from plus to minus, and this is just a critical point. It's neither max nor min because there is no sign change, and this will be relative minima because it is changing from negative to positive over here. Okay, fellas, a similar question, that double derivative is given and we need to find where h have an inflection point. Okay, where does h have? So again, the double derivative should be 0 and undefined. Undefined is obviously not possible, and it should change the sign. Remember, critical and inflection, these are a little different. So it is 0. I think I don't need to, you already, I hope you know that you just equate the individual factors to 0 just like that. So from here you're going to get 2, from here you're going to get -1 and -5 from here. So you make a number line, -5 here, -1 here, and 2 here. Okay, any number greater than 2 that you like, maybe 100. If you put 100 here, that will definitely be positive. Anything between these two, let's put 0. And once again, guys, I'm not really going to ask this guy again and again about his sign because that is always positive. It's a square. So if I put 0, these two are also positive. If I put -2, then this is negative, and remember it's a cube, so it will stay negative. And this is positive, so negative. And anything less than -5, maybe -100. So this is negative, so double negative will make it positive. So fortunately, there we have two guys who are point of inflection. Remember, this is not a point of inflection because there is no sign change. So x equal to -5 and -1 are the points of inflection. Then they're asking on what open interval is h prime increasing. H prime is decreasing. H prime is decreasing wherever its immediate next derivative is negative. And this is indeed the sign chart of h double prime. Where is it negative? Here, and well, only here. So the answer is -5 to -1. That's where h double prime is negative, so h prime is decreasing. And where is h concave up? H is concave up wherever h double prime is positive. And h double prime is positive means that h prime is increase. I mean, why am I going that far? I don't need that because I have the sign chart. So h double prime is positive, and yes, the other intervals we can just clearly see that it's -infinity to -5, union -1 to 2, union 2 to infinity. Fair warning, guys. I've seen students answering this guy as -1 to infinity. It's not correct just for one small reason, that you have to exclude x equal to 2, because at x equal to 2 the double derivative is 0. It's not positive. These are the zeros of that. So make sure you make that you have that break in your interval. All right, fellas. Question number 12, xe to the x, they're asking that for each of the following values of x, does the graph of k has a relative extrema? Okay, I think same old school. I need to find derivative of this, but unfortunately, product rule is calling us now. So x times x remains as it is, derivative of e to the x is e to the x, and then e to the x as it is, and derivative of x is just 1. I'm going to take e to the x out, and then x plus 1. That's what I have. For relative extrema, I need the critical point. For critical point, I need to set this to 0 or undefined. It cannot really be undefined. I don't really see any such thing. It's not a rational function or something. So it's just 0, which means that e to the x times x plus 1 is 0. E to the x is never 0. I mean, I hope you remember from your algebra class that e to the x just keeps increasing. It never hits this x-axis. It's actually an asymptote for it. So only x plus 1 can be 0, which makes x as -1. So if x is -1, need to find the sign change of it, and sign change means of k prime, right? Anything greater than -1 may be 0. No need to ask e to the x again and again, because like I said, e to the x is always positive. It's above the x-axis. So if you put maybe anything on the right, maybe 0, so that's going to be positive. Anything on the left, maybe -2 or -100, that's going to be negative. So they're asking for what values of x it has relative extra. Okay, so it has relative minima, not maxima, at x equal to -1. So please make sure you have that as minima, not maxima. Okay. This is based on a table pretty popular in AP, guys. Sometimes they ask 2 or 3 questions as a together based on the single, single table. So the table gives the f prime and f double prime of 2 guys, f and g. They're asking if g is an implicit function of this, if h is an implicit function of this, then is h increasing or decreasing at 2? Or h has a horizontal tangent? To answer any of this, I need to find h prime. So h prime is going to be g prime fx times f prime x. I need to find at 2, so h prime 2 will be equal to g prime f2 times f prime 2. Okay, what is f prime 2? This is the 2 row, and this is f prime row, so it is 3. And what is f2? f2 is, there you go, f2 is 0, so g prime 0. And what is g prime 0? This is 0 and this is g prime. G prime 0 is 2, right? G prime 0 is 2. So that's going to be 2 times 3. 2 times 3 is of course 6. 6 is a positive number, so this means that h is increasing. H is increasing uh, at that particular point. So my answer is increasing. Right. Likewise, we have Q function, which is this. So is Q concave up or concave down? So unfortunately, this goes to 2 iterations. I need to figure out the double derivative. Q prime is going to be f prime 2x times 2, which is 2 times f prime 2x. And if we find the double derivative, q double prime, so 2 remains as it is, and f prime 2x derivative will be 2 f double prime 2x using the chain rule. So that's 4 f double prime 2x. That is q double prime. They're asking at x equal to 1. So q double prime 1 is 4 times f double prime 2. F double prime 2, so at x equal to 2, f double prime is 2, right? At x equal to 2, f double prime is 2 if I'm reading it correctly. So 4 times 2 is 8, so 8 means it is concave up. All right. Does the graph have a relative minima or maxima or neither at x equal to 0? Let's figure out. X equal to 0, guys, is right here. Now this is x equal to 0 line. Now is that a critical point? First off, yes, because f prime 0 is 0. And if we need to find the relative extrema, just find a sign of f double prime x, which is the second derivative test, right? So since f double prime 0 is a positive number, it is a relative minima. I hope you understand. I have used second derivative test, not the first derivative test, to figure out the relative maxima or minima. We cannot even use the first derivative test because in the vicinity of x equal to 0, we don't know. I mean, you might think that we know negative 2 and 2, but these are not the immediate vicinities. We need the sign chart and exact all the critical points, etc. So second derivative is the safest choice over here. Does G have a relative extrema or neither at x equal to 4? Let's figure out. At x equal to 4, is G prime 0? Yes, it is 0. At x equal to 4, G prime is 0. And G double prime at x equal to 4 is negative, which means that again using second derivative test, this time it is a local maxima. So using second derivative test, it is a relative maxima. Find the equation of the tangent line when x is negative 2. So first off, I need to figure out the y coordinate. So p of negative 2 will be f negative 2 cube. What is f negative 2, guys? F of negative 2, there you go, 3. So 3 cube is 27. So the point that I have is negative 2 comma 27. I need to find the slope as well. So the p prime value, the p prime is going to be 3 times fx square times f prime x using the chain rule. If I plug in negative 2, then p prime negative 2 is 3 times f of negative 2 square times f prime negative 2. So this will be 3 times, what is f of negative 2? F of negative 2 is just 3. So I'm going to plug in 3 here. So this will be 3 square. And f prime negative 2 is? F prime negative 2 is right here. F prime, this is negative 2, this is f prime. So this is negative 4. So that's negative 4. 3 times 3 is 9. 9 times 3 is 27. 27 times 4 is, I think, 81, right? 7 was 28. Carry 2 4 0 9. Sorry, 108. Yeah, 108, negative 108. So this is the slope and we need to find the equation. So I'm just going to write equation over here. It will be y minus 27 equal to negative 108, x minus minus 2, which will just become x plus 2. So this is going to be our equation for E. And F, increasing or decreasing, once again, this is just the f prime thing, guys. So for the f prime, unfortunately, we need to use a product rule here. So m prime x is going to be f prime x times gx plus fx times g prime x. So m prime negative 2 will be f prime negative 2 times g2 plus why is that g2? G negative 2. G negative 2 plus f negative 2 times g prime negative 2. Okay, all right, let's move up and get the values at negative 2. I'm just gonna shade it, otherwise I will be lost with so many values. And I'm looking for first f and f prime. Let's find f and f prime. So f is 3 and f prime is negative 4. Okay, f is 3 and f prime is negative 4. And g prime. G is 4, g prime is also 4. Great. 4, 4. So there is 4 and then there is another 4. 4 times negative 4 is negative 16 and 4 times 3 is 12. So this guy is negative. So this is, since derivative is negative, the function is, what am I saying? The function is decreasing at that point. So the derivative is negative, which means that the function is decreasing over here. Well, that was a long question, guys. I hope you understand. Right. All right, guys, doing something light now. These are multiple choice. Light doesn't mean easy. Light just means that these are multiple choice. So we are given h and we need to figure out which of the following could be h prime. All right, I think I'm interested in looking at the maximas and minimas first, because the maximas and minimas of h prime are clearly where the derivative is 0, because these are, you know, horizontal tangent, or maybe by the first derivative test we know that. So it looks like the derivative should be 0 at a negative number and at a positive number. Clearly not a derivative is not 0 in the negative. Clearly not b, it's not 0 anywhere in the positive direction. And c, d, and e are definitely strong candidates, just keeping that thing in mind. Okay, what else? I think I'm talking about increasing, decreasing now, because wherever the h prime is increasing, h is increasing, the derivative should be positive. So the derivative should be positive during this highlighted interval, right? Let's see if the derivative is positive. Okay, clearly c is gone, because c is behaving exactly opposite. On the left side of this, it is negative, right? It is going in the negative direction, which is definitely not something that we want. So this is gone. And this makes sense because it is positive here and then it is going negative in between, and it is positive over here as well. So it has to be either of D and E, but then I'm again noticing, I mean, I know that the answer has to be E, because my logic says that this looks like a cubic function, and derivative of cubic is a square, square is a parabola, which looks like E. But okay, if anyone of you is not convinced with this logic, then look at this now. We are talking about concavity. Look at that. If you notice carefully, this is all frowning in nature till this point. And then it is smiling. Frowning means h double prime is negative, which also means that h prime is decreasing in nature. But look at this portion. It is not decreasing, it's increasing slightly. I want completely decreasing and then completely increasing. So this logic also corroborates our understanding that it has to be option E. I hope you understand the logic. Okay. Now this is vice versa. Here we are given f prime and we need to figure out what is f. So once again, the logic still stays the same, guys. Wherever f prime is 0, for example, you know, this one where f prime is 0, so fx has to attain a local max or min. It cannot be A, it cannot be B, it's not attaining any max or min. C, D, and E are definitely attaining a max or min at these points, so that works. Now another way, another important thing is f prime is positive between negative 2 and 2. It means that the function should be increasing from negative 2 to 2, because f prime is positive. But here the function is increasing and then decreasing and then increasing. Here the function is increasing, and here the function is decreasing. Since I only need increasing, it has to be option E clearly, because it has to be increasing because the derivative is positive. All right, guys. Let f be a function that is continuous in the interval -2 to 3 such that f prime does not exist, f prime 0 does not exist, f prime 2 is 0, and f double prime is negative for everything except 0. Which of the following could be the graph of f? Okay, if it is continuous in -2 to 3, how can D be the answer? Because it looks like D is discontinuous, right? There is a break over here. There are two separate pieces. So D is gone for that reason. F prime does not exist, F prime 0. So F prime 0 does not exist means, at 0 it has a vertical tangent or a sharp corner, etc. But look at C. C does not have any such funky stuff. In fact, we can easily draw a tangent at 0 and find f prime 0. So that's gone. Yeah, A, B, and E have sharp corners, so they are not defined. Now they are saying f prime 2 is 0. It means that at 2 I have a local max or min. Unfortunately, all three are meeting that criteria, so this is not helpful for us. And f double prime is negative for all except x equal to 0. F double prime is negative means function is concave down. But how can A be the answer then? Because this is smiling in nature. Concave up, not allowed. How can B be the answer? It is smiling in nature all the way, not allowed. Yes, E is the answer because it is frowning here and it is frowning here as well. It's concave down. That's what I want. So the answer must be E, guys. I hope you understand. Right. Here we are given that y is a function such that its derivative is positive and double derivative is negative. So which of the following could be a function? I think that's pretty straightforward, because if derivative is positive, it means that the function is always increasing. So it cannot be C because this is decreasing. It cannot be D because it is decreasing after this portion. So it has to be the remaining three. And they are saying that y double prime is negative, which means that it is concave down always. It cannot be A because it is a smiling in nature. It cannot be E because it is smiling during this portion. It has to be B because it is continuously frowning in nature or concave down. Okay, fellas, optimization. All right. Rancher has 200 feet of fencing to enclose two adjacent rectangular corrals as shown. Find the values of x and y that will maximize the total area. All right, fellas, this is x, this is x, this is x, y, and y. 200 feet of fencing means that sum of all these boundaries is equal to 200, which means that I have 1, 2, 3, 4 x's and 3 y's that should add up to give 200. What is the idea of optimization, guys? The idea of optimization is first to optimize means making anything maxima or minima. So first you might want to find the function that you have to maximize or minimize. In this case, the area. So the area is definitely xy plus xy because there are two small rectangles. So it's 2xy. And in order to maximize or minimize anything, you will differentiate. But you will have two variables in such questions. So in order to do away with the other variable, you have a condition given in the question. And using that helpful equation, you find that third variable, plug that back in over here so that this is only in terms of x. Then you differentiate and then you use the candidates test, of course. That's what we are looking for. So over here, I'm gonna find that 3y is equal to 200 minus 4x, and y will be equal to 200 minus 4x over 3 over here. So the function is going to look like 2x times 200 minus 4x over 3. So that looks like just 2 over 3 times 200x minus 4x square. If you want, we can take 4 out as a factor as well from 204. So it will look like 4 times 50x minus x square. So it's 8 over 3, 50x minus x squared. That's how it looks like. Although I said candidates test, but 99% chances these things doesn't maximize or minimize at the terminal point. Because at the terminal point, for example, in this question, if you notice, the terminal value of x, as in the maximum value of x, is 50. But at that 50, the y will just become 0. So it doesn't make any sense, like practically doesn't make any sense. So first derivative test mostly works here. I'm gonna find the derivative, which is 8 over 3 times 50 minus 2x. Equate the derivative to 0, which means that I think only this is equated to 0. So 50 minus 2x is 0, which means that x is 25. And that's about it. 25, anything greater than 25 will make this guy negative. Less than 25 will make it positive. So yes, we do have a maxima at 25. What are they asking? Values of x and y. Great. I have x as 25 over here. And then what is y? Y is just plug in 25 over here. So 200 minus 25 times 4 is 100 over 3. So that's 100 over 3 feet, or what? Feet, yeah. So these are the dimensions, guys. X is 25 feet and y is 100 over 3 feet. That's our answer. Okay. This is a very popular question asked in various ways, just the language changes and the concept is same. Okay, this one says that a lifeguard stationed on the beach sees a swimmer in trouble 150-meter down the beach, and 60 meters out in the water. So this is the swimmer who is in trouble. This is the lifeguard who is one, and he's seeing this swimmer at 150-meter down and 60 meters, into the water, out in the water. The lifeguard can run at 5 meters per second on the beach and swim at 3 meters per second. What path along the shoreline and out into the water should the lifeguard take to reach the swimmer in the shortest amount of time? In other words, they are saying that he ran till some point, then he jumped. So find what is that, what distance along the shoreline he should jump so that the time is minimized. So let's say this is x over here, right? So obviously this will be 150 minus x. And using Pythagoras, I can find this one, which is square root of 60 square plus 150 minus x square. Now we need to minimize the time, right? And what is the time? Time is distance over speed. So the function of the time, the function that we are looking for, is the time on the beach plus time in the water. Time in the beach is distance ran on the beach over the speed on the beach. Speed on the beach is 5. Time in the water is distance in the water, which is just the Pythagoras. Of course, it's a gross expression, but we cannot do anything about it. And swim at 3. Fortunately, we already took the variables into consideration such that we don't have anything except x. So all we need to do is differentiate and equate to 0. So f prime will be 1 over 5 plus this will become 1 over 3 is as it is, and this will become 60 square plus 150 minus x square raised to, if we differentiate, then 1 over 2 comes down and the power is negative 1 over 2. We go inside and then derivative of 60 square is 0, and this will be 2 times 150 minus x times minus 1. That's how it looks, right? I've used chain rule. And this should be equated to 0. I'll do that in the next step. So 1 over 5, and then this is 1 over 6, and then this is just 1 over square root of 60 square plus 150 minus x square. And this is, remember, this is negative 2. So negative 2 times 150 minus x. Finally, this can also be written as 1 over 5 and negative 2 times 1 over 6 is negative 1 over 3. So negative 1 over 3, 150 minus x over square root of 60 square plus 150 minus x whole square. Oh my goodness. Okay, equating that guy to 0 now. So I'm gonna get 1 over 5, minus 1 over 3, 150 minus x over square root of 60 square plus 150 minus x square is equal to 0. I hope you understand that I will bring this entire thing on the right side and it will just become positive. So if I just edit this equation, this will just be equal to, I hope you understand. I'm going to cross multiply, so it will look like 3 times square root of 60 square plus 150 minus x whole square is equal to 5 times 150 minus x, correct? We'll keep solving. This is no calc, so I'll square both the sides. This is 9 times 60 square plus 150 minus x square is equal to 5 square is 25, and this is 150 minus x square. Okay, if I distribute this thing, so it will become 9 times 60 square. These are not smileys, just so you know, these are just imply symbols. Plus 9 times 150 minus x square is equal to 25 times 150 minus x square. Subtract 9 times 150 minus x square both the sides, so this will become 16 times 150 minus x square over here, and this is 9 times 60 square over here. I think we can simplify this a little bit because it looks like this will become 3600, and this is 16, and this is 150 minus x square. I think this can go away with 8 because 8 times 2 is 16 and 8 times 4 is 32 and 8 times 5 is 40 and then 0. And then this can again cross out with 2 times 2 is 4, 2 times 2 is 4, 2 times 5 is 10. So it's 225. Okay, I think that's actually very good for us. You'll understand in a minute because both of these are perfect squares. I'm just going to write this one on the left side. So 150 minus x whole square is equal to 9 times 225. And if I take square root both the sides, then 150 minus x is equal to square root of 9 and 225. And fortunately, square root of 9 is 3 and square root of 225 is 15. So 150 minus x is this. So 150 minus x is 45. So minus x is negative 105. So x is 105. If you're thinking that when I took the square root over here, I should have taken plus and minus sign. Yes, I should have taken plus and minus sign, but it won't make any practical sense because then the answer would be greater than 150, which does not make any sense. It has to be less than 150. So 105 is the value of x, which is in meters or what? Meters. This is the value, or this is the distance that that the lifeguard has to run on the beach and then jump so that he can reach in the minimum time. Again, you might be wondering that I have not found the sign change of the first derivative because how do I know this is a minimum? This could be a maximum as well. Yes, you are right, but again, in such questions, they don't go this far that they will make you find the sign chart and all as well. The value that we get is most likely, I'm not saying it is 100%, but most likely it's a safe way to assume. But if you are really want to make sure, then feel free to plug any number of your choice that is less than 105 and greater than 105. Maybe put 1 over here and you can get a number approximately, and then put probably 120 or I don't know, maybe 150 also will work because 150 will just make it 0. And if you put just 0, in fact, this will make everything this much greater and it will become negative. So it is going from negative to positive, so it has to be a minima. Okay. And finally, the last question, this is calc active, thank God. So the wall of a building is to be braced by a beam that must pass over a parallel fence 5 feet high and 4 feet from the building. So this means that the fence is 5 feet high. So let's say this is the fence, this is 5 feet high, and this is 4 feet from the building. And let's say this is where the building is over here. Let's say this is the building. And we have to find the length of the shortest beam that can be used. So the beam must glance through, this fence and will look something like that. So this green guy is the beam. So let's connect these things. So it looks like a similar triangle the moment we draw it. That's what we might need to, find over here. So let's figure out that what we need, what the length of the shortest beam that can be used. So basically they need the value of the green guy over here, right? Okay, fair enough. So let's call this as X, right? And this building is Y. And I need to find Z over here. But honestly, I can find Z as soon as I have X and Y because I can use Pythagoras, right? Now, like I said, and like you agreed, I hope, that these are similar triangles. So can we agree that 5 over x, why they are similar, by the way? Because these are 90 and this angle is common. So using AA similarity. So 5 over x is equal to y over not 4, 4 plus x. Be careful. So cross multiply. 5 times 4 plus x is equal to xy, I think. So 20 plus 5x, sorry, 20 plus 5x, yeah, is equal to xy, which means that 20 plus, I don't know why I did all that. I could have, okay, anyway, 20 plus 5x over x is y. So I got that. Now, what is z? Z that we have to optimize. So the function that we are looking for, which is z, is nothing but square root of y square plus x plus 4 square using Pythagoras. And we have y already. So we have that in a single variable, which is 20 plus 5x over x square plus x plus 4 square. So we need to figure out where this derivative is 0 and it changes from positive to negative. That's our, sorry, negative to positive because we are looking for the shortest beam, and that's our answer. So that's where Desmos comes into action over here. So this is my Desmos over here, and I'm gonna type in the function as it looks on the other screen. First, I'm gonna place in square root. Right, guys, if you type this in, it is going to look like this. Obviously, you might be wondering that how can x be negative, but don't worry. Zoom out a little, and there you go. You have this function right here, which is minima. So there are two ways actually, guys. If you want to make sure that this is the function and you are finding f prime x, so just hide this and now see that f prime x should be 0 and it should change from negative to positive, right? So there you go. This is the point that you're looking for, where f prime is 0 and f prime changes from negative to positive. So I got the x value, but I need the function's value at this point because I need the length of the ladder or the beam. So f of 4.64 and what was that? 159. 159. So that's what I have. That's what I have. The length of the beam comes out as L is equal to 12.70, and that's the number that we are looking for. So that should be our answer. Also, I hope you guys know that Desmos is now allowed in AP. It's sort of like hybrid. So that's why I've been using Desmos in all my unit review videos. So I hope these questions made sense to you. I hope you learned something. Again, guys, if you found this helpful, please like and subscribe. Please share it with your friends. And if you need private tutoring, feel free to reach out. I'm going to see you in the next video. Bye-bye.